Okay. It's been a while. It's been a while since I put video and a podcast up. And it's not for the lack of trying. I have been rethinking a little bit about what we're doing and what we want my channel to be about. I am clearly passionate about the transition and the energy transition that's happening and all the technologies surrounding that experience. We've been making some plans, and I'm thinking that what my channel needs is more information around getting through the noise, making videos for YouTube, making podcasts, and the ins and outs, at least on some of the basics that exist if you want to do something like this, right? And this particular channel has always served two purposes. And I don't know that people know this because I don't think I ever talked to the audience, but it has two purposes. One was to demonstrate that you can use media, YouTube channels such as this, to reach out to people that ordinarily wouldn't want to talk to you, right? So if you have a business and you are trying, especially for B2B businesses, you're trying to reach out to others. If you have a podcast, if you have a YouTube channel, you have something to give as part of that experience, and you get a chance to, at least for a short moment, to connect with someone who probably is exceptionally busy and probably wouldn't otherwise talk to you unless there's something in it for them a little bit, right? And so this channel and the last 7 years of me making these types of podcasts and videos definitely proves that concept down. The other side of that coin has been all the experience of learning what it's like to do this kind of stuff, like the equipment, like creating something in your home or using a studio or professional or not, like just the variety of the constellation of technologies and decisions that are associated with like making content. And I'm not going to say I'm like the best content maker. Clearly not. Look at my channel. My channel doesn't have like millions. I'm not Mr. Beast. It's just not. It's not going to, maybe it will, probably won't happen ever, right? It's likely never to happen. But in terms of a concept as a tool, as a way to grow your own network or your brand, or whatever it is that you're trying to do, it's absolutely fantastic. And I think that's what's driven me into this space over time, maybe a little bit kicking and screaming, to the realization that this is a way of communicating with others and creating opportunities, especially when you start from a place where you don't have much to give, right? You don't have much to offer. This is a great tool for that. I'll be making more videos about this, the concepts around it, what's happened to me, what's happened to the business that I run. Today's episode is a particularly awesome one because I get to talk to a CEO who's made an airplane that flies on batteries. And I wanted to figure out, like, really, A, is that really even possible? B, I mean, does it work? Does it work? And what makes a company and its investors pile in the money for a plane that is probably extra heavy, right? Because batteries are heavy. And it's interesting because what I learned from this guy is that there is this market fit, as they say, for the type of plane that you would get when you design the plane around its battery. So without further ado, I guess we're going to get into this episode, and I hope you watch it. I hope you like it. Gregory, thank you. Thanks for joining me on the show. I really appreciate it. I know you're super busy. CEO Gregory Davis of Eviation. Okay, I got to ask you right off the bat. So planes powered by batteries, they do fly. They do exist, right?
That's right, Ernesto. Look, thanks very much for having me. It's a lot of fun being here. And yes, electric aircraft are real and amongst us right now. And here at Eviation, we're making the world's first all-electric commuter aircraft. It's the first plane of this scale to ever fly electrically.
Okay, you've got to give me a sense of what that what that's like, because it's like, I always think batteries, they're heavy. It's kind of it's a benefit when you're talking about cars, right? It kind of spreads the weight, lowers the center of gravity on the car. It makes it more stable to go around corners more, and that's why there's those Teslas and other EVs are super fun to drive. What's it like on an airplane? How's that work?
Batteries have a lower energy density than conventional aviation fuel. And so when you're making an electric airplane, you really need to design the plane around the batteries, right? So you need to make sure that your airplane has the best possible aerodynamics. So it's as smooth as possible, as well designed as possible. And also need to make it as much of it as light as possible to give you room to deal with those batteries that we have in the aircraft.
And I would assume then it's also, you need to think of like the use cases that are optimal for for the jet. It's like a jet, right? I kind of looked at your website. It looks like a jet. It's got room for how many people? Can you give us a sense of that?
Yeah, well, you're actually hitting on what we call the sweet spot of electric aviation, which is again the size of the aircraft, the technology that we're using to make it work and to make it accessible, and it comes down to what we call the three C's: to carbon, cost, and convenience. So carbon, obviously, it's a zero emission aircraft. It's electric. There's literally no tailpipe on the airplane, so nothing comes out of it when we're flying. Electric electric energy is cheaper than that same energy derived by burning jet fuel, right? So when you're taking energy off of the electrical grid, it's going to cost you less. And also, the electric motors are much simpler than turbine motors. There's really only one moving part on an electric motor, so they're going to cost less to maintain. And in terms of convenience, what this allows us to do, having an affordable energy source, a clean energy source for our aircraft, it means that we're going to be able to start introducing aircraft back into regional air routes that we really haven't seen serviced properly for decades.
Okay, interesting. Because I just to realize, like, okay, if you do a regional air route, you have to have enough fuel on both sides of the leg, right? Because you got to refuel that means more like a tank, gas. You got to bring the gas. I'm sure there's all that stuff, but here you can fly into a place and then plug it into the electric grid that may exist there, right?
Yeah, absolutely. So as we build out our operators, we start delivering airplanes into the fleet. The operators are going to set up point-to-point air travel. So one of our customers is a company called Cape Air out of the eastern United States, and they've been operating for decades, have a fleet of over 100 aircraft. And what they're going to be doing is taking Alice and putting it onto existing routes. Now, the routes that they fly are short range. They typically take less than an hour to fly. They're less than 200 nautical miles. And that's very closely matched with the type of range that you're going to get from Alice as it enters into service. Now, in time,
That's the name of the plane.
the name of our plane is Alice. And actually, just to take it back a bit, on September 27th of 2022, we actually flew Alice for the first time, and it was the first time that an all-electric aircraft of this scale has ever flown. If you get a chance, there's some great videos online that you can watch, and you can see the aircraft do its first flight. But what's really impressive, it's not just the fact that we built and flew the aircraft, it's that all of the technology that's needed to commercialize an electric airplane was demonstrated on that flight.
So why are regional lines been cut back? Is sort of like that you said it earlier that we used to have more of them, and then for some reason they've been cutting back. Why is that?
Yeah, so 40 years ago, there were regulatory changes that came in, and it actually changed the shape of aerospace of airline operations, certainly in the United States, and similar effect around the world. And there used to be tons of regional airlines that would operate, 10 to 19 seat aircraft on regional air routes, and there was a whole set of airplanes that were designed to service that market. But when the regulations changed, we saw consolidation in the space. We also saw a push towards bigger aircraft. We call it, like taking the bus, where you go to the central airport, the terminal, the bus station, and then you fly to another one, and then you get off and you complete your journey through some other means, whether it's road or some cases rail. And that's the way that the industry has gravitated. So we've gone to this sort of hub and spoke model of flying. But yeah, 40 years ago, you'd be able to do a regional point to point. And if you look at the United States, there is a very well established airport infrastructure. We've got 5,000 airports around the US alone. And there's similar stats in other parts of the world, but just focusing here in the US, of those 5,000 airports, 2,000 of them have been designated by the FAA as being underutilized, and a full 500 of them, or only 500 of them, so about 10% of the airports that we have are actually used for regular commercial air travel. So there's a large amount of infrastructure that exists that we're just not using. And it's mostly driven by cost. And what we're able to do with the electric plane, because of the lower operating cost from electricity versus jet fuel, and because we're able to introduce new flights without increasing their carbon footprint, we're going to actually change it around. We're going to make it so that people can fly between small airports again.
I see. Interesting. So then, because how much is the cost differential, like for the Alice sized plane duration relative to what they used to have in terms of fuel? Like, what would we be talking cost savings associated?
Yeah, so depending on where you are around the world, it could be anywhere between 1/3 and a tenth of the cost to get power from electricity. And that's in today's marketplace. We're also seeing regulatory changes and things like carbon taxation. And in some places, you actually get a tax holiday on aviation fuel to help benefit the industry. And those types of incentives are actually going to go away. And on the regulatory front, we're also seeing countries like France and Norway take some pretty major action in terms of what people are allowed to do with their airplanes.
So you're seeing, like, if anything, fuel costs may the likelihood of fuel costs going up in the future is higher than the likelihood of fuel costs going down in the future, just given like the regulatory atmosphere around carbon emissions.
Yeah, and we've seen it in all sorts of other fuel costs, heating fuels, home heating fuels, and other applications, automotive fuels, in many regulatory environments. And so that's definitely the direction that things are headed.
Plus, it's there. I always talk about, like, not always, but when I talk to friends that are skeptical about electric cars, I just mention that, the combustion engine cars, they're leaky. There's a lot of leaky. There's got to be oil. There's got to be gas. There's got to be some coolant. There's like a lot of liquid stuff in there. And that's why the roads get sometimes slick. I mean, I would assume that it's like an engine is more complicated. You mentioned it. There's only like one major moving part in an electric engine, right?
Yeah,
The magnetic thing that spins whatever, right?
it's the bearing. It's the bearing that moves, right?
That's it.
Yeah, that's it. Yeah,
You don't have to worry about anything else.
yeah,
Moving fuel and moving, the coolants. You don't have to worry about any of that. Making sure levels are okay.
yeah. We jokingly say that it's going to have the maintenance of your ceiling fan, right? So it's the same type of setup.
How often do you check your ceiling fan for functionality? I don't know.
Yeah, that's right. So with the aircraft, with the electric motor, we are absolutely going to have to do inspections as per normal practice for aircraft components. But the likelihood of there being, major wear is very low. So that's going to push to longer maintenance intervals in time as more confidence is developed, as the technology comes on. So it'll just get better and better.
So what are some, like, I guess you could call these the puddle hoppers? You got the electric puddle hopper, Alice. But what are some of the, like, use cases for regional transportation aside from people, right? Like, they can deliver some goods. They can maybe between major hospital systems if they have, like, I don't know. What are some out there that you think can be viable for your product?
Yeah, so we've got three versions of the aircraft that we're bringing to market. The 9-passenger commuter aircraft, which we see as being a game changer in terms of how people travel. And then you're absolutely right. So let's talk about cargo. And another customer that we've actually got who's been very, very supportive of our program is DHL, right? And DHL as a company has been very forward-looking in their approach to environmental sustainability. So it's a great match. But DHL is going to use the aircraft for cargo routes, as you said. And you look at the size of the airplane; it's actually a bigger plane for its passenger load than you would normally get. And that's because we've had to accommodate the batteries. What that means is that you've got a bigger cabin size. And with the advent of smaller package freight and things that we order online and that want to have delivered the next day, the density, so the weight of a package versus its size, has actually continued to go down. So what that means is that these aircraft that we're using, or even trucks that are being used to move packages around, they'll actually fill up with boxes before you used up all of the weight. And that's really not very efficient from a usage perspective. You want to use up all your weight, not the volume. So with the premium size cabin in Alice, you can actually get more volume of packages for the available weight, which works really well with the trend in packaging. And the other thing, of course, is that being an electric aircraft, the other advantage you get is the aircraft's very quiet. So the electric motors, there's no turbine noise. They make no noise at idle. And then we're designing the airplane with noise in mind, so to make it a quiet aircraft.
Because that's a factor, right? Also, if you're regional, you're flying maybe lower altitudes or something, or you're trying to get into smaller airports and areas where there might be more, neighbors that don't want to hear a bunch of noisy planes.
Yeah, absolutely. And it's all around the world. I mean, going back just to the U.S. figures, there's 200 airports, that actually operate with noise restrictions. And that means that you're not even able to fly out of them half the day. So with the electric plane, we're going to be able to bring new aircraft into market and have them flying from airports. And it's not going to bother people because the airplanes are going to be so quiet.
Like, how do they measure the I mean, it's obviously decibels of something, but like, what's that process like to be able to compare between a regular plane and?
It's a great question. So yeah, decibels are one of those measurements that are a little bit hard to get your head around because it's logarithmic. And so rather than show numbers at you, what I will say is that if you think about a typical business jet taking off right now, so you're at an airport, you hear that jet going by, and maybe you're in the parking lot and you hear it, you look up, you hear the jet. The difference that we're going to have is roughly the difference between that. And then I'll be generous and say that's a minivan going by while you're in that parking lot.
Are you serious? I mean, are we comparing a giant jet or like similar comparable Alice-sized jet?
Let's say similar. I mean,
Similar.
there's a lot of variation in noise there, but it's going to be a pretty significant difference.
Even with the propeller, I mean, it's propeller. I see the picture of one of it. It's like this propeller version of it, right?
Yeah, that's right. And so part of it, airplane design. I mean, going back to what Alice is, it's an airplane, right? It's purposely an airplane. It's been designed around the batteries, but it's been designed to be certified as an airplane. And part of airplane design, you control the design of the things like the propellers and the fuselage and how they interface to optimize your noise profile. And so over and above taking advantage of the electric propulsion technology, we're also making sure that the aircraft's engineered to be quiet inside and out.
Wow, because then that gets you into into your target markets, potential markets that have been also concerned about air noise pollution, right?
In the United States, 60% of the population lives within 10 miles of an airport, and 95% of the population lives within 25 miles of an airport. But when we go to an airport, we drive for over an hour, to get to the nearest major hub. That's typically how we fly, and it means that just in the home to airport, the destination from the runway travel, we're adding hours on to what we need to do, and it's not convenient. You have the need for security lines in large airports that you don't require in small fixed base of operation type airports where you're going out, you're getting on a plane with 8 other passengers and flying point to point. And these operations do exist right now. I mean, Cape Air is an example of a really well-established operation. There are also a lot of new companies that are looking to take advantage of the airport infrastructure. And what we're going to offer them is the ability to do it without harming the environment.
This is like just, to me, this seems like super new tool, right? For me, for just hearing this idea of this concept of just using battery operated. Like if you had talked to me, 10 years ago, I wouldn't like, what? Batteries are so heavy. That's not going to, right? No, somebody would have done it by now. What got you, what got you into this work, and what has the team at, Eviation, what was that watershed moment that like made it like, hey, we should give this a shot. We should try to build this.
So our company was founded in 2015 in Israel, and our co-founders were involved in the battery industry and had the realization that the technology was getting there. It was getting to the point where you really could build a usable electric airplane. And more than just the airplane, the batteries, pardon me, there's also the propulsion technology, the motors that were also coming to the point where things were starting to align. And they had the vision to pull together Eviation and to say, okay, we're going to take on this challenge. Since then, the company's evolved further into into an aircraft manufacturer. We're going down that road right now of becoming the type certificate holder for the Alice aircraft, which means that we as a company own all of its design and how it's going to be used in service from a design perspective. So it's a real evolution that we've gone down. But the fundamental realization is the need for sustainable aviation. And, aviation and flying, it's not the enemy, it's our friend. It's incredibly valuable to us. It's carbon that's the problem. And so the technology is going to allow us to overcome that challenge.
And but when they were courting you to be the CEO, what was that like? I mean, did you automatically have some idea? Were you already in this world, or did they have to pitch it to you raw and you're like, is this for real? Like, can this really happen?
So I'll tell you a story about 2019. I'm an aircraft person, so I've been in the aircraft industry for my entire career. I started off with a glider pilot's license through the Air Cadet program in Canada when I was 16 years old. I got my private pilot's license when I was in high school. We used to
flying your whole life.
Yeah, we told our teachers. My friend had a car. I didn't have a driver's license, but I had a pilot's license and a plane I could rent. So we would occasionally tell our teachers, it was a nice afternoon, and say, do you mind if we just skip class this afternoon and go flying? And our teachers never really had a problem with that. They said, that's fine. Yeah, go for it. And then I did a couple of engineering degrees. So I've got a bachelor's and master's degree in aerospace engineering. I used to design modifications and upgrades for military aircraft. And then I actually skipped over and ended up in aircraft production. Running an engineering department in an aircraft factory, and then ultimately running the factory building planes. And then I switched over into the aftermarket world, actually. So running the global support for about 2,000 aircraft around the world. But in 2019, I was at the Paris Air Show, and the chalet, the stand that we were at with the company I was with at the time, was right next door to where Alice was on display, right at the front of the air show. And so every day I walked by the aircraft thinking, gosh, what is that thing? That's amazing. And at the same time, we're also looking at sustainable technologies in aircraft. And so when the opportunity came up to sort of join those two things together and to work with Eviation to help advance sustainable aircraft and sustainable technology in aerospace, I was very excited to come on board.
So they already had the prototype built. They were demonstrating. You happen to notice it, and then it just started more questions for you as to what that's all about. And from their perspective, is they were just exiting building the first one. Now we got a manufacturing that makes a perfect sense fit for you, right? Given your background.
So the proof of the original aircraft that was at Paris, it actually had 3 motors on it. And which led to a unique configuration with a lot of really, really good ideas from an aerodynamic perspective, or a range optimization perspective. But one of the things that's happened in the meantime is the motor technology continues to improve. And so whereas before, you had to design the airplane around a 350 kilowatt motor, we've got 650 kilowatt motors now. So you only need 2 instead of needing 3. So those are the types of technology changes that actually have a fundamental impact on the design of the plane. And you'll see lots of aircraft concepts out there with some 10, 20 motors on them, small motors typically. And then you've got Alice, which has a more conventional configuration with 2 motors on it. And it's because the technology is allowing us to do that.
And so that, I mean, then you're sort of optimizing down to the particular routes that makes the most sense. You don't want to over engineer something just to try to like make an all electric giant passenger plane. I'm sure there are people trying to make that happen, but that might not be the first stage of that's not where the biggest business need might be at the moment, right?
So going talking about carbon, talking about reducing emissions. I mentioned cost is a critical factor here. The people who operate our aircraft are businesses, right? They use it every day to perform their tasks for their passengers or for their cargo customers. It's got to be a useful tool from that perspective as well. So in terms of when you're engineering the product, you need to make sure that you're engineering something that people can afford to use as a means of getting that technology adopted so that we can start impacting the carbon footprint of aerospace in a positive way. Um, with that said, the society of the sweet spot for the airplane, it's ultimately an airplane, and the path that we're taking is to design it so that it's certified under existing standards, and it can be operated by pilots with existing pilots licenses, using existing training techniques, and we fly from existing airports out of existing airspace. So it's about fitting the aircraft in. And then in terms of the size of the aircraft, it's a 9-passenger airplane on purpose. And it actually goes back to cost because 9 passengers is the limit for single pilot operations. So you can actually fly a commercial aircraft with 1 pilot and 9 passengers on it. So if you had a 10th passenger, you need to have another pilot, which increases piloting cost, increases the weight on the airplane. And then you get to the batteries. And batteries are your energy. So you need energy to carry around weight. And so when you add batteries to the airplane, you actually need that energy to carry the batteries around as well. So there's a diminishing return in terms of how much weight you can add to the aircraft. And that's really driven by the available energy density of batteries. So it will improve, batteries are improving reliably. The same technology, lithium-ion technology that improves by about 3% per year. And then new technologies that are very exciting are coming on right now, which will offer step change, incremental changes in what we have from an energy density perspective.
How do you deal with, like a question like how long does it take to recharge the thing, right?
So the aircraft's modeled, again, it's an airplane. So we want it to operate the way that people are used to airplanes operating in as much as possible. And things like charging and the life cycle for a battery are actually design considerations. So you choose your technology, you choose the way that you've designed your battery.
The right chemical mix and all that to make it can you charge 80% of it faster than the last 20% you might not need to?
Exactly right. Yeah. So it's exactly right. So for us, it's a matter of what do people want to do with the plane, and we've targeted a 30-minute charge will give you 1 hour of flying time.
Okay, which might be plenty for quick
It works. Yeah, you can. The model works, right?
Washington to Baltimore or something fast, right?
Actually, let's talk about that for a second. So you think about these routes, and 250 nautical miles range at entry into service, and what does that mean? Well, half of all of the world's air traffic is all flights are 500 nautical miles or less. But depending on where you are regionally, um, 20 to 30% of all air travel is actually 250 nautical miles or less.
Oh, right, because you're doing the 1 hour down to the airport to fly to the other airport and drive down. You might actually be closer. Just right. You might be within the 200 miles.
Yeah, so where you've got geography and other factors that come into play. I mean, we have our flight test facility that we've been using out of Moses Lake in Washington State, and our headquarters is in Arlington, Washington. And it's about a 3.5 hour, 4 hour drive depending on conditions. And if you want to go there for a couple of hours, either for a meeting or to tour the aircraft or for whatever technical reason, maybe there's some work to do on the plane. Typically, it ends up being an overnight trip, of which 8 hours is spent driving. Now, if you used Alice to do that same flight, it would be about a 45 or 50-minute trip. You could go and come back, within a few hours. So, I mean, the savings, and you think about 9 people doing that at once, the total productive time savings and that type of usage of an airplane are really easy to calculate. And that's why this form of travel is actually very popular where it's used. And we want to make sure that can be expanded out more, which is part of why we're doing what we're doing.
Yeah, and I can just vaguely visualize, there's like you drive in the country, you're in the middle of nowhere, and then suddenly there's a giant distribution center from Amazon and a little ecosystem of a town that's around that, and other manufacturers suddenly pop up because it's like a centralized distribution center for that. I could see potentially as this grows as a tool, they might build factories within those ranges of something like this, so you can shepherd your experts between different factories or different whatever business units. Yeah, it's like, wow. What is the well, it's designing the first one, prototyping it, that's its own level of challenge, and then once you have it, that's a big win, a celebration. But the next real level of complexity is to start scaling taking in the orders and then building around a factory that can actually generate these things, right? Where are you in that space? What's that like right now for you guys?
We're using the approach of strategic sourcing to make our planes. So we're going to be mindful about how much we scale as an organization. We've demonstrated our expertise in the electrical integration of the high voltage electric systems on the aircraft. It's the power plants, it's the flight controls, environmental controls, and all of the instrumentation and control, pilot controls that go with it. So that's our forte, and also, we know how to design an electric airplane. But there are lots of companies out there whose strengths are in producing wings or producing fuselages, and you see, I mean, that's what major manufacturers do as well, is they outsource major components to people who are really good at making them, and that's the approach that we're going to take. So we're going to be very mindful about where we scale and where we grow, so that we protect our core competency, and don't overexpand into areas that other people can already do as well as we need them to. So that's our approach to industrialization.
Yeah, because half the difficulty of designing, let's say, the wings is just getting enough material staged well enough in advance. Like that's a whole world of just making a wing, right? And so if somebody's already worked all that out and can get it at a certain cost price point for you, that makes sense. But are you manufacturing then the battery components and the engine, or like what's the main manufacturing that you're sort of going to stay on top of?
We're ultimately going to be the company delivering the aircraft to our customers.
Okay.
So that final assembly of the airplane, where it gets finished to the customer spec, and then handed over to the customer and transferred to them, we're wholly accountable for that. And also, yeah, absolutely, we're pushing to evolve the integration of the battery and motor technology onto the airframe. It's a critical role. It's one thing to make the components; it's another thing to actually make them work with an airplane. And that's again where our strength lies, and we'll continue to control that.
What are your targets for, like, how many units are you going to start thinking you can get to, or if you want to share that? I don't know if that's proprietary or not.
No, well, you know what? Here's what I'll say. You look at the marketplace, and you look at what other similarly sized aircraft can be built at in terms of a production rate. And I can share that we've got over 300 aircraft on pre-order right now. Right, so that's out there. And you look at average production rates and how long people want to wait for an airplane, and we'll be scaling up to production rates similar to other similarly sized aircraft. We certainly see a very attractive market for our airplane, and we want to make sure that we get it into our customers' hands as soon as possible.
What is the fancy addressable market for this? Like the size that potentially is out there, if you're talking to, investors.
There are thousands of opportunities to get the aircraft into service. And the way that it breaks down is, if you look at our orders and our customers, all of whom, it's a two-way agreement when you're signing up with an aircraft company and a customer, because we want our customers to benefit and be able to use our product, but we also want to learn from them. And so I would say that both sides have been, really intentional about who we're working with. And right now, about 3/4 of our orders are coming from existing air operators, and the remainder is from new companies that are actually starting up, in no small part because of the new availability of our technology. And so it's enabling that usage case that we were talking about reinvigorating regional travel. So you look at that, and what we're really seeing is that there is an existing market and then a new market for electric aircraft as well.
Well, it's like anytime you create a new tool that you're trying to find the customer base that's got the most pain now to buy, that would be willing to pay the premium of a new product because it just fits them so well. And then the market grows a little bit because then others start to see, oh, wait, you got that. And how did that work out? Oh, maybe we could use that here, but they never even thought of, right? And so some of that takes time. But I guess the fortunate thing of building aircraft is that there is a lag time to building the air, right? These aren't deals that happen like, over a weekend. You're not buying a Tesla car. You're buying an aircraft that's probably somewhat bespoke, and a conversation has to be had pretty extensively throughout the build process, right?
Yeah, and we're involving our customers in those discussions right now.
Right, to optimize the type of unit that they're going to really want. And so from there, you also then learn like who are the customers that really need it at a certain spec point that could be future potential customers down the line, right?
Absolutely. Yeah, we learn a lot from our customers.
I'm wondering about the I guess, I mean, it's like without knowing more about like how much thrust and torque and these things do, what is the thing that someone piloting this thing the first time, what would they remark about? Like a seasoned pilot's been flying around. What's the thing that they kind of go, what? Or is there anything? Or does it just feel just like normal, like flying a normal plane? You just happen to have batteries.
It's an airplane, and so personally, I've flown our simulator a number of times, and there's a lot of direct similarity between the way that the aircraft is controlled and a conventional airplane, that's a turbine airplane. The instrument displays are a little bit different. So going back to some of the technology that we've had to invent, we had to come up with the displays for how electric energy is represented on the aircraft in a way that makes sense to a pilot. And that's new because previously it was fuel levels and percent torque and RPM and things that get measured in your engines. And now we've said, okay, well, what really matters to the pilot? So we've had to invent some of that, but it's very intuitive. It's very intuitive, and look, it's a strange analogy, but I think that most people of I would say the piloting generation have at some point in time played a video game. And different games have different ways of showing what your speed is, what your throttle is. You adapt to it pretty quickly, and it's really no different. It's that. The point I'm trying to make is how simple it is to actually switch your thinking to electric once you're in the airplane. It makes a lot of sense very quickly.
Doesn't have extra boost power or something. It just doesn't do tighter turns or something.
There's
But that's not the point.
no upgrades that exactly, that you can fly through, get a ping or whatever, not yet anyways. Though I'm laughing because going back to electric cars, some electric cars actually do have a game function built into them where if you're flying in the sweet spot, they give you rewards in your screens and so on. But I don't think we'll be doing that.
Okay. No, it's just more, right. It's serious business here, flying an airplane. But this sounds really exciting. I guess one of the questions I have is like, you're going to be an international company, right? I mean, you could take orders from anywhere in the world. Who has the most restrictive regulatory environment for carbon emissions now? That, to me, I would think might be more customers there available, ready to go.
In terms of the country that stands out as having done the most aggressive approach is actually Norway.
Norway.
By 2040, they're just banning everything that pollutes. So I mean, it's a pretty aggressive approach.
They're not playing around.
No, they certainly aren't. And we've seen other countries that are indicating that they're looking at doing, I'll say in some cases similarly aggressive approaches. But I mean, the entire World Civil Aviation Organization, the ICAO, it's agreed to dramatically cut emissions globally by 2050, which is 27 years from now, but not very long in terms of aircraft. I mean, honestly, you get on an airplane that might be 20 plus years old right now, and you don't even realize it because they still look new and so on, right? So I mean, this is what we're talking about.
That's true too. And so like your growth trajectory is probably 20, 30 years, right? Because it's in the sense that you're not going to maximize your marketplace is when you still have when it takes 20 years for a fleet to sort of turn over. It's similar in, I guess they even talk about it similar in cars, although cars, I guess it's more like 10 years, but right. So there's so much more room to grow into this space. This sounds really exciting spot.
It really is. And in that 10 years, with your battery technology improving, you're going to have aircraft that maybe can fly a bit farther, can carry more payload, or can fly a bit faster, and that'll evolve in time as well.
And to the extent that that changes, then you just redesign the fuselage to account for those differences.
There's a lot you can do with the existing design. So we've been very mindful about the fact that battery technology will evolve, and we need to be able to adapt to it. So our battery systems are future compatible on the aircraft, and you'll be able to just upgrade your battery and immediately access the additional performance.
That's half the business for you guys is like keeping an eye on what that battery technology is going to look like and what's coming around the corner and what the cathodes or the chemical makeups, all that. Keeping an eye on that.
Absolutely, we're an electric airplane manufacturer. It's incumbent on us to make sure we keep on top of the electric technology.
What's the most common when somebody sits down for dinner with you and they don't know anything about and they find out that you make electric planes? Like, what's the most common question or misconception perhaps people have about it that you have to sort of dance around not to hurt their feelings about?
Oh well, I mean, look, it's a good news story all around. So I've never encountered a worry of hurting anybody's feelings, not yet. But you've touched on it. The number one question I get is the range. How far can it go?
The range.
And it's because most people equate airplanes and cars as
Going to California from
yeah. And so in a car, when you get in your car, you want to be able to get in your car, and go wherever you want to go, as far as you want to go, whenever you want to go there. And with an airplane, it's totally different. So in an airplane, you want to go to the airport that you wanted to leave from, leave at exactly the time you wanted to leave, and arrive at the airport you wanted to get to at exactly the time you were meant to arrive. So it's a totally different equation from the idea of the open road. And again, going to how people actually use aircraft. Most people only have access to large aircraft commercial travel right now. It's different from what was 30 or 40 years ago, but today that's what we experience. It's single or double aisle jets for the most part, and it's actually giving people the chance to see that they'll be able to take advantage of regional air traffic again. Being able to go and see a friend, Seattle to Portland or pick anywhere. And then, you can play this game anywhere on Earth almost, and pick two cities that you'd like to go between. And think, okay, well, I can go and do that zero emissions in a quiet and comfortable environment. It's very exciting for people. So I'd say that's the number one thing.
I would assume this could be really exciting for those regional, small, those private little airports that exist that, have had pressures from the community to lower their noise pollution, to lower the, emissions, all kinds of issues around that. I bet that this might be an interesting, opportunity for them to, if they can get customers that have these planes, they might be able to open up more routes, more something, right?
Yeah, the economic benefits are huge, right? You think about from a business perspective, from a freight perspective, being able to get your packages in, or in the case of small industries, your packages out on that daily basis and have them go to market. Being able to commute back. A lot of people have changed their living circumstances in the past 3 years, and people have moved out of big cities. But now that the offices are starting to reopen, there's actually a draw or a pull to get people back into the office a few days a week.
Good luck.
But to be able to, what if it was just a convenient day trip where you used your access card, you got on your flight for 35, 40 minutes in the morning, you went to the office for the day, and then you got on your flight for 35, 40 minutes in the evening, and were home 10 minutes after you landed at the airport. That's what we're talking about. It's real and achievable. And as people are doing this right now with conventionally fueled aircraft, and we're going to give them the opportunity to change over to zero emissions.
It's quieter, it doesn't pollute, and it can get you perhaps faster to a location than you can building more roads or having more cars or whatever, that it might just work out better to look at one of these units. But that does bring up the question of average cost. I don't have to get specific, but I'm wondering what in the universe you're in, what does it look like for somebody to be interested in owning this?
There are some individuals who would be able to afford Alice easily. That's not our principal marketer.
No, no. Yeah, but I mean, as a we're talking about the billionaire ballers here in this world. But like a company that wants to perhaps own two or three of these to start a commuter service of some type, what are they looking at?
The cost of the aircraft is comparable to existing planes of the same size. So it's the initial purchase price will be maybe a little bit more than what you would pay for the same aircraft with conventional engines, but it's well offset by the operating cost. So yes.
It's new technology, so it's always going to be a little more expensive because you're not yet scaling at the points where you can reduce. That's just the way it is. But given that you can knock off a third to a tenth of your fuel, sorry, up to 9/10,
30 to 90% or
30
better.
to 90%
Yeah.
could be huge in terms of, and then you just
It is. It's the single largest cost for most airplane operations is fuel. But so I mean that's a real motivator. And then we expect that there's going to be other factors that will come into play, like as I said, taxation on the tailwind side to help us and challenge the other parts of the industry.
maintenance. I mean, overall maintenance costs. Like what? Yeah, like by how much? Do you have a rough idea in that regard, or just it depends?
We certainly do. I mean, we've mapped it out versus a number of different aircraft. You have to look at the whole spectrum of what you're comparing it against, but it's a sizable reduction in maintenance costs. Namely, the engines themselves are going to be much cheaper to maintain.
Is there like some pushback from regulators you expect a little bit? Like, what do you mean we can't? We have to check you off on the engine, right? Because part of the maintenance is also like a check off process, right? That the equipment's functioning. There's like, well, there's no actual moving part engine here.
No, it's fine. It's fine. It'll be no problem. I mean, not worried about that at all. Just do it. Just show them that it's fine.
It's like, look, ball bearing.
Yeah, it's fine. Yeah, exactly. It's here it is. It's clean. It works the way it did yesterday.
Yeah.
Yeah, no, not concerned about that in the slightest.
That's really exciting because, I think there'll be, you just got to find maybe a billionaire or two to give you the capital investment to buy a fleet of these. But this is huge. But this is huge. This is a big game changer. And there's nobody else yet here. I'm sure you have some competitors out there coming up, but
We're ahead. We're ahead of anyone else in this sector. There are lots of exciting new aircraft concepts in the sustainable aviation world and the advanced air mobility sector. In terms of regional air mobility, we're quite comfortable that we're in the lead.
I think I just think that's an excellent spot to start overall. You're not competing with the giant, jets. You don't need to. You're solving a problem that has a gap. It has been having a gap for a long time, and here could be a new way of just transportation overall. This is amazing. When's the IPO going to happen?
Yeah, we're not talking about that, but I'll tell you that entry to service of the aircraft will be in 2027. And so for you and me and everyone else, that's when you'll be able to start flying in Alice.
Is there going to be one company ahead already in schedule is there going to be a route, or are you going to disclose that once you get closer to?
Yeah, absolutely. We'll confirm once we move forward. I mean, certainly, we've had such great support from companies like Cape Air and DHL and all of our customers, but they've certainly been with us since the very beginning.
Right. But the 2017 is the date for you and I to try one.
2027. Yeah, we'll be on one. I might be able to sneak a flight before then, but I'm not going to tell you.
The boss can,
Yeah.
Well, Gregory, thank you so much. I mean, that was an hour, it just flew by. I really appreciate this. I think this is super exciting spot to keep an eye on. Please, let's keep talking, especially as you eat into some of the 300 pre-orders you already have, which is amazing. That's just like there is a hunger for this stuff. I think a lot of people know the transition to electrification it just has to happen, and everybody's just trying to figure out who are the players that are there closest that can deliver on the goods right now. And it definitely sounds like you guys are moving along. So best of luck on this, and I do mean it. If you do go IPO, let me know.
Thank you. Of course. Thanks very much, Ernesto.
You're welcome. And thank you guys for, those of you that are looking and checking out this show. I'm trying to get better. I'm trying to make these more interesting, whatever, all of that. But what's important here is to understand that I care about getting this transition going and helping highlight the stories that it's actually happening. So, and Gregory, that you're one of those stories. So thank you so much.
Thank you.
Bye, everybody. Take care.
Visit throughthenoise.us for more episodes and subscribe to our newsletter. This show is produced by Through the Noise Consulting, uniting external communications and internal IT functions to ensure data and privacy are protected while creating innovative communications platforms. Want to start your own podcast? We can help. Visit getthroughthenoise.com to learn more.